Okay, we're going to solve some log equations. So I'm going to start out with a real simple one. Let's say the log of x is equal to 1. What does that make x? Well, I'm just going to rewrite the number 1 as a log. And if I was to write that as a base 10 log, that is the base 10 log of 10, because 10 to the 1 is 10. So now I have the log of x is the log of 10, therefore x is equal to 10. Another way I could have seen that is I could just take that and rewrite it in exponential form. Our base is 10, our exponent is 1, x is 10 to the 1, which is 10. Okay, so if this is not perfectly clear, maybe review the introduction to logs. And now we'll do slightly more challenging problems. So let's say we've got 1 minus the log of w minus 7 is equal to 0. Okay, I can rearrange this. 1 is equal to the log of w minus 7. And if I was to rewrite 1 as a log, it is the log of 10. So the log of 10 is equal to the log of w minus 7. So 10 is equal to w minus 7. So w must be 17. So all we've done here is we took our equation that involved a log, we rearranged it so that we just had the log of one thing on this side and the log of something on that side, and then whatever we were evaluating the log of had to be equal to each other. We're just going to continue to work with this strategy as the questions become more involved. Now let's say I've got 9 is equal to the base 5 log of x plus 100. And I'm adding 6 to that. Okay, so tricky looking question. Let's go for our strategy where we're going to try and get the log of one thing equal to the log of another thing. So I'm going to keep the base 5 log on the right. Base 5 log of x plus 100. And I'm going to subtract 6 from both sides. So I've got that. Now, nine minus 6 is 3. So the base 5 log of x plus 100 is equal to 3. I now want to write the number 3 as a base 5 log. I'm going to do this real quick, and then I'm going to do this slower with more steps along the side, because I think this is where it might get a little bit challenging. How do I write the number 3 as a base 5 log? It's actually the base 5 log of 125. That's equal to the base 5 log of x plus 100. So 125 is equal to x plus 100. If I subtract 100 from each side, I will see that x is equal to 25. That's my solution here. X is 25. Now, of all of this, I would imagine that the most difficult step for you guys is to go from the number 3. How does the number 3 just turn into the base 5 log of 125? Well, if I start out with the number 3, and I want to write this as a base 5 log, I need to understand that the exponential form of an equation where 5 is the base and 3 is the exponent, 5 times 5 is 25 times 5 is 125. So that's an exponential equation, and the log version of this equation is that the base 5 log of 125 is equal to 3. Because 3 is the exponent, you would have to raise 5 to get 125. That allows us to employ the strategy here, where I've got the log of a number on one side is equal to the log of the variable we're looking for on the other side, which allows us to then solve it. Okay, so I'm now just going to pick a slightly trickier question out of your book and work my way through that. So now I've got 1 plus the log of y is equal to the log of y plus 9. Now the problem here is, how do I end up with a solution where I just have a log on each side, where I actually have 3 terms here, not 2? So I'm going to go, I'll leave the 1 here, and I've got the log of y plus 9 minus the log of y. And as I'm subtracting the logs, I'm going to employ the rule and look up the video on the sum and product rule for logs if you're not sure what to do here. The log of y plus 9 minus the log of y is the log of y plus 9 divided by y. So the difference between the logs is the same as the log of the quotient. Now I'm going to turn 1 into a base 10 log, and that is the base 10 log of 10, because 10 to the exponent 1 is 10. So 1 turns into the base 10 log of 10. That's equal to the log of y plus 9 over y. So that means that 10 is equal to y plus 9 over y, as long as y is not 0. Going to multiply both sides by y, so I've got 10y equals y plus 9. And if I subtract y from both sides, 9y equals 9, which implies that y is equal to 1. Okay, so here, again, I can solve this if I have the log of one thing is equal to the log of another thing, and then those things must be equal to each other. In order to get that, when I had 3 terms, I wanted to turn it into 2. And I turned my 3 terms into 2 by using the quotient rule of logs. That's what simplified this equation so that I could work my way through it. Okay, so now I'm going to do one last example. And this one will turn into a quadratic, and then I'm going to find some extraneous roots. You see here, if y is equal to 1, let's check to see if this works. If y is equal to 1, then we've got the log of 10, which is defined, and the log of 1, which is also defined, so we're good. I'm now going to do an example where we have to watch out for our domain, because we can end up with a domain error. The base 2 log of x plus 5, let's say that minus the base 2 log of 2x is equal to 8. Now remember, you can only take the log of positive numbers. Because you can't raise 10 to any exponent where it's going to give you a negative number. This only works with positive numbers. That's the domain. So the domain of this first term here, the base 2 log of x plus 5, is only going to be valid when x is greater than or equal to negative 5. Well, actually strictly greater than negative 5. X can be negative 4 because negative 4 plus 5 is 1. But if x is negative 5, negative 5 plus 5 is 0, and there is no base 2 log of 0. Because what that's saying is, what exponent must you raise 2 to give you 0? And there's no answer for that. Okay, so I'm going to employ the usual strategy to solve this. So I've got the base 2 log of x plus 5 divided by 2x. And that's equal to 8. I now want to write 8 as a base 2 log. And 8 is 2, 4, 8, 16, 32, 64, 128, 256. It's the base 2 log of 256. So the base 2 log of x plus 5 over 2x is equal to the base 2 log of 256. Let's verify that. I'll just run that through the calculator. If I take 256's log and divide it by the log of 2, that gives me 8. So yeah, 8 is the base 2 log of 256, because 2 raised to the exponent 8 gives you 256. That's where you get that from. Alright, so now from here I can say that x plus 5 over 2x is equal to 256, or x plus 5 is equal to, that's going to be 512x. And finally, if I subtract x from both sides, 5 is equal to 511x, or x is equal to 5 over 511. And does that work? Turns out that that's just fine, because 511 times 2 is a positive, and 5 over 511 times 2 is a positive, and 5 over 511 plus 5 is also a positive. So this is all well defined, and the solution works. Okay, I'm going to find one last example for you here. The log base 3 of n squared minus 3n plus 5 is equal to 2. Okay. So how do I turn this into simply a log on each side? I just have to rewrite the number 2 as a base 3 log. And if I took 3 and raised it to the exponent 2, it would give me a 9. So the base 3 log of 9 is equal to 2. So I can rewrite 2 as the base 3 log of 9. So the base 3 log of n squared minus 3n plus 5 is equal to the base 3 log of 9. Therefore, n squared minus 3n plus 5 is equal to 9. Or I could rearrange that, n squared minus 3n, and then if I was to subtract 9 from both sides, that would give me a minus 4. That's equal to 0. So I need two numbers that will add to negative 3 and multiply to negative 4. So those numbers are n minus 4 and n plus 1. So n minus 4 is equal to 0, or n plus 1 is equal to 0. That makes n equal to 4, or n is equal to negative 1. And then I'm going to check, and yeah, both of these numbers work just fine here, because neither of those numbers cause me to take the log of a negative. So this is all well within the domain.